Thank you for your introduction, and thanks to the organizing committee for inviting me over. Since we're pressed for time, I'm going to try to go through this as speedy as possible. It's great that the medicinal use of cannabis is now gaining ground across the world. So with literally every month there's a new country that is embracing medicinal cannabis. However, in order to have successful implementation of the use of cannabis as a medicine, we feel that there is still a couple of big issues that we need to deal with. And one of the major issues is knowledge. The science behind the medicinal use of cannabis is only about 20, 30 years old, which means that most of the healthcare professionals that we are all dealing with have absolutely no idea what this is all about. And for this reason, we decided to create a website that contains all the tools and knowledge that medical professionals could use to prescribe cannabis in a meaningful way. Now, I had planned to take you through this website, but technology has abandoned me, so now I'm going to try to talk you through it, and my colleague is going to try to point out what it is that I'm talking about. The good thing is that even though the website was built in English, it is available in every language, including Portuguese, so hopefully you can see what I'm talking about. Now, if we go to education and start with the introduction, I would like to first briefly talk about the why. Why is medical cannabis all of a sudden so relevant? And it all revolves around the endocannabinoid system. And now, what is the endocannabinoid system? For this, I would like to take you back about 300 million years in time, when life evolved from single-celled life to multicellular organisms such as us. We consist of hundreds of billions of cells that somehow all know what to do, and that's quite remarkable. For this, nature had to invent some new rules of life. The first rule is cell division. Cells need to know when to divide. If a bacterium decides to divide, that's fine, as long as there's enough energy, you can do that. If in your body a cell just starts dividing and never stops, you talk about cancer. So you need rules to convince the cell not to do this. So on the one hand, you can't have cells dividing to prevent cancer. On the other hand, sometimes cells forget to divide or forget to stay alive, and this is when you end up with degenerative diseases, such as Alzheimer's, such as Parkinson's. So either way, your cells need to know when to divide and when not. The second rule of successful multicellular life is energy. Cells need to know when to absorb energy so that they can grow, and when to just let it pass for other cells in the same body to use it. And if this process is disturbed, you can either get fat, or you get too thin, or you get diabetes. Either way, metabolism needs to be carefully monitored. Now, the third pillar of successful multicellular life is cells need to recognize whether the cell sitting next to them is a colleague cell of the body that they need to protect, or whether it is an invader that they need to kill in order to prevent infection. And if this regulation goes wrong, you can either get, well, lots of infections, or you get autoimmune diseases where cells of the body are being destroyed by the body's own immune system. So this needs to be carefully regulated. And the final pillar of successful multicellular life is cells need to communicate to each other. And when this goes wrong, well, there's a whole range of neurological diseases where you can see what happens if this goes wrong. So all in all, these four pillars need to be carefully balanced, and this is exactly what the endocannabinoid system does. And sometimes the endocannabinoid system gets overpowered, or there's a mutation in it, and then you need other agents to restore balance. And by pure coincidence, there's a plant that grows that makes substances called cannabinoids that do exactly this. And this is the essence, the key to cannabis-based medicine. Now, if we go to the next item, I want to very briefly place cannabinoids in the metabolic web. So everything you eat gets, well, churned up, broken down into elements, and then redistributed either into carbohydrates, which is the energy part of things, or into proteins, and there's a third category, those are the lipids. And these lipids are not just the jackets that surround the cells, but they have a lot of signaling functions as well. Now, plant cannabinoids are lipids that are built from isoprene blocks, which are sort of Lego blocks. And you can stack them to form different types of molecules. So if you have one of these isoprene units, you typically have the smell of, well, what is it, pears or smelly feet. Add another one, you get menthol or related substances and a lot of classical terpenes. Make 3, you got the smell of ginger or hop. Stick 4 together, now you got cannabinoids. And you can go even further. You can stick 10 together, you get Q10, which a lot of people put in creams to keep their skin youthful. And put 30 together, you got latex. Now, endocannabinoids are slightly different. They are all formed from diacylglycerol, which is a very central component of our metabolism. So what am I trying to say with this? These cannabinoids are very natural substances. So now I'm going to try to explain how cannabinoids work. It's of course impossible to explain the entire endocannabinoid system in one slide, especially if you're talking about 50 different diseases, but here we go. So cannabinoids are formed from the cell membrane, or endocannabinoids, by stimulation. So this could be nervous stimulation or mechanical stimulation. Either way, you stimulate a cell and some cannabinoids are being formed that can then bind to any of, well, about 40 different types of receptors. And these receptors can then signal in the cell to multiple different targets. That's divergence of signaling. At the same time, a lot of receptors can actually convey the same message. Now, I'm not going to make it more complicated than necessary, but all these signaling cascades basically inform the cell nucleus of 2 things. One is the energy status, which is formed by the balance between ATP and ADP. Never mind what I mean. And the other one is the oxidation status, which is formed by the balance between reduced and oxidized substances in the cell. Now, in normal life, cells are mildly stimulated. There's a gentle signal going through the cells, which basically informs the cell nucleus. Everything is okay. Don't change a thing. Now, if the cells are stressed, then they are pushed a little bit more cannabinoids are released, your energy level sinks and your oxidation level increases, and it signals to the cell, do something. So it will just make random adjustments until things go back in the green. If they don't go back in the green, you go further into the red, and this instructs the cell, kill yourself before you kill the entire organism. And if that goes even further, then the immune system kicks in and the cell is eliminated. That is usually how cannabinoids work in normal signaling. Can we go to the next? So now I'm trying to go slightly towards how do we take this information into meaningful information to prescribe medicine. So you can, of course, ingest cannabinoids. Oh, it's a bit big. Anyway, I'll go quickly through this. There are many different ways for you to take cannabinoids to you, and they all have different effects. For instance, if cannabinoids are smoked, you get a very quick effect, but a very high level. But if you take cannabinoids under the tongue, it goes through different pathway in the body, it goes through the liver, half of it is being converted into other substances which have their own functions again. And you need to be aware of all these differences before you start prescribing, because maybe you won't hit the right effect. And well, there are several other options that you can take cannabinoids, and they all come with their own profiles of activation. If we go to the next slide. Now let's see what happens with the most well-known example of cannabinoid application. What happens when you smoke a joint? The top panel, you see what happens with THC. So on the horizontal bar, you see all the receptors that can possibly be activated by cannabinoids. And every red bar you see is one that can be activated by THC. And if you look at the red box, that is more or less the levels of THC you can expect in your blood plasma when you smoke a joint after 10 minutes, 30 minutes, and 120 minutes after smoking. And you see that in the case of THC, most receptors that can be activated are activated at some point by THC, which is a good thing if you want a therapeutic effect. However, if you look at CBD in the panel below, CBD is hardly present in cannabis as we know it, and you see that actually none of the receptor functions are activated by smoking a typical joint. This is where you need to start looking at other ways of taking cannabinoids to you. Now, if you go one step further, you see the same, don't be alarmed by this, by the way, but you see every possible interaction you can get between cannabinoids and receptors. This is the essence of cannabis-based medicine, and this is what we need to research further in the future. So what I just showed you was what happens in the blood. But of course, not every function in your body is regulated by the blood. And we also know that if you have cannabis in the bloodstream, or cannabinoids in the bloodstream, you get different levels in different organs. For instance, if you look at the lungs, you get about 100 times more cannabinoids accumulated than if you look at the blood. And the brain is somewhere, well, most organs are somewhere in between. Now, if we go a bit down and integrate, yeah. So here you see the last picture, but now with the different levels incorporated. So you see that, well, as I just told you, smoking THC will pretty much address most receptors, but at different levels in different organs. And if we go a bit down, we look at CBD again, and I just told you that smoking a joint which hardly contains CBD, there's no real function. But if you do smoke real pure CBD, you actually hit levels that are high enough to address the functions that you want to address. So this is something to remember when you're a physician. You see that sublingual application or smoking or topical application has dramatic different effects on the body and therefore different therapeutic effects. Now, can we go back to education? Yeah, that one. Sorry. Another thing to remember is that everyone is different. Everyone has a different genetic passport, and this also includes the endocannabinoid system. Everyone has a different endocannabinoid system, meaning that we all respond differently to cannabinoids. And also, it means that we are prone to different diseases in our life. Here is a collection of all mutations that we are aware of in the genes encoding the endocannabinoid system that make us prone to a whole range of different diseases. This is something that we need to take into account when devising a therapy for a particular disease. Now, there are a lot of other categories in the educational part, but I'm going to skip that for now. I would like to show you, if we go to diseases, how all this knowledge can be used by medical professionals to actually come up with a therapy, a personal therapy. So if we go to, let's pick epilepsy as a disease. So we have basically trawled through about 40,000 scientific publications and categorized these by disease, by receptor, by endocannabinoid, by plant cannabinoid. And we tried to put this all together into a manual for physicians to come up with a therapy. So if you look at epilepsy, on the top panel, there's some general information about the disease and some other things you can read up on. But in the panel below, you see these are the phytocannabinoids that scientific research has implicated in epilepsy. And if you click to the next one, endocannabinoids, again, these are the two endocannabinoids that we now know are somehow involved in epilepsy. I'm not saying that they cause epilepsy or they will be the cure, but they are related. So it's a handle for us for the future. Then if we go to the receptors, you see these 4 receptors have been implicated in this disease. And then to terpenes, 2 terpenes we now know have some influence on the disease. Now, if you are a physician and you want to come up with, okay, what am I going to prescribe? You might first want to look at the receptors again and see, okay, click CB1. Now we get all the information that is known about CB1. And if we go down a bit, it's the most important bit of information, that is, where is it expressed? So we know CB1 is primarily expressed in the brain, which is good if you're talking about epilepsy. And so for all these receptors, we have this information, and then you can see, okay, this receptor is apparently involved in this disease, but hey, hold on, the disease is in my liver and it doesn't have this receptor, so forget about using that as a therapy. That's more or less the idea behind this. So apart from all the general information, if we scroll a bit down, there's all the literature that concerns epilepsy, categorized, and so you can read through it and see, okay, these are the researches that have been done, and this is what I can take from it. And if we go a little bit up, there's also a section with clinical trials, so you can see, okay, what has actually been tested in humans. Now, this is one thing. This is the bottom up. So you take science and you do your test and you come up with a medication. However, cannabis is different from all other medications. Namely, it's safe. It has an unprecedented safety record, meaning we can actually try things and then from that distill what may be the mechanism. And this is also what we're working towards. And the last thing I want to touch upon is a patient questionnaire, which I think is translated a bit weird in Portuguese, but it's not an interrogation. But we are inviting everyone who has a personal experience with cannabis to inform us, okay, I've used this strain and it works best for these aspects of the disease, or whatever. So it's a list of about 170 questions in different modules, depending on whether you are a patient or a recreational user or a religious user, or you are a doctor that is treating a patient. And we are trying to accumulate all the information that will tell us these are the cannabinoids that are good for this disease, these are the terpenoids, or this is the strain that is best used to treat any particular disease. Well, I think I should leave it at this for now, so I will welcome the other speaker, who I think will talk about this some more. Thank you.